Yes, dear learners, today I want to welcome you to our lesson of today, and I want to thank you so much for being good followers of our lessons. I believe today also is going to be an interesting day, and we are going to learn something from what we are going to learn. So I will just request you one thing. I want you to tell your neighbor to settle down and be very attentive, such that we shall all move together up to the end of the lesson, and hopefully by the end of the lesson each one of you will have understood what we are going to look at today. As you look at here on the chalkboard, our lesson is going to be about types of numbers. We are going to look at different types of numbers. Of course, in mathematics we have always dealt with different categories of numbers, and we are going to understand that numbers are grouped differently, as we are going to look at today. So there are quite many types of numbers we have in mathematics, and we shall begin by listing them down. After listing those different types of numbers down, we are also going to take a step and we shall try to understand each of them one by one. So we shall begin with number one type of numbers we are going to look at is whole numbers. We shall try to understand what whole numbers are. We shall also look at the second type, and that is natural numbers. All of us, natural numbers. And the spelling of the word natural is the very natural that you know. I know in SST you learned about this word. Are we together? So even in mathematics, the word natural is just spelled the very way it is spelled in SST. So we are going to understand what we call natural numbers. Then we shall move further to look at even numbers. We shall also look at odd numbers. Mind you, it is odd numbers, not old numbers. We don't have numbers which are new, and neither do we have numbers which are old, but they are called odd numbers. Odd numbers, spelled as O-D-D, and the word is odd. Are we together? So we have another type of numbers called odd numbers. We shall also look at the fifth category of numbers, and that is prime numbers. All of us, prime numbers. So we are looking at prime numbers. Then we shall move further to look at composite numbers. Composite numbers. Composite numbers. Then we shall look at triangular numbers. We shall look at triangular numbers. Triangular numbers, coming from the word triangle. And then we shall have number 8, square numbers. We shall look at square numbers. Here we are just listing them down, and then we shall go further to understand each of them. Then we shall also look at, I think this should be the final one, we shall look at cube numbers. Cube numbers. And maybe lastly, let's add this one also. We have another type of numbers called integers. We have another type of numbers called integers. So for today we are going to stop from here. We are going to look at right from whole numbers. We shall come straight all the way up to integers. Remember, all these are different types of numbers. So we want now to move further to understand each of them one by one. We shall need to understand what whole numbers are. Are we together? Yes, want to understand these types of numbers that we have just written here. Remember, when we're writing, we're just listing them. So when you look at our list of types of numbers, it has a complete list of around 10 types of numbers, right from whole numbers, natural numbers, all the way up to the final type of numbers we are going to look at, which is the integers. So we want to begin straight away with whole numbers. We want to understand what whole numbers are. Of course, whole numbers in natural understanding, they are numbers which comprise of 0 and natural numbers. So when you combine 0 together with natural numbers, which are the same as counting numbers, of course, when I talk of natural numbers, I am talking about counting numbers. And when I talk about counting numbers, I'm talking about those numbers that we pronounce when we are counting. So if I told you to count up to 10 at this very juncture, I know most of you know the numbers which you are going to pronounce. You know the first number, and that is 1. You go to 2, you go to 3, you go to 4, and so on. So those are what we call counting numbers, which are also the same as natural numbers. So the moment you combine those counting numbers or those natural numbers together with 0, then you've come up with what we call whole numbers. So we can simply say whole numbers are a combination of when I talk of the word combination, I am talking about getting two things to make one group. I am talking about picking different things and then you collect them together. Then you come up with one unit of those different things which have been collected together. So whole numbers are a combination of 0, which I'll put in the brackets, and all positive numbers, Of course, when I talk of positive numbers, I am talking about counting numbers. Counting numbers are all positive numbers. Counting numbers. So all counting numbers, those numbers that we pronounce when we are counting, they are taken as positive numbers. We can say whole numbers are a combination of 0. So ideally it means 0 is a first whole number. So when you are listing whole numbers, you begin from 0 and then now you add on the rest of the numbers must be positive numbers, which are basically counting numbers or natural numbers. So we can give an example. So we can say, for example, we can have whole numbers like 0, 1. Remember, I've begun from 0 and then now I'm writing positive numbers, or else I'm writing counting numbers. The first counting number is 1, followed by 2, followed by 3, 4, 5, and many more. They are endless. Whole numbers are endless. When you are learning about sets, there is a way we call those types of sets which have got endless or countless number of members. And those sets are called infinite sets. They are called infinite sets. They are called infinite sets. Even here, whole numbers, if it is just something which is open, they give us an example of an infinite set, because I've just listed some of them, but there are so many more. There are so many more which are remaining. So to show that I have many more whole numbers remaining, I just put 3 dashes, or I put 3 dots. Of course, mathematically, the 3 dots or the 3 dashes, they refer to infinity. They refer to infinity. Natural numbers. So I'm going to write here natural numbers. Natural numbers. Natural numbers. So when I talk about natural numbers, I think if you are not very careful, I have already explained about natural numbers. The time I was explaining about whole numbers, I talked about natural numbers. I said natural numbers are the same as counting numbers. If you know counting numbers, then you know natural numbers. Natural numbers or counting numbers, they are those numbers that we pronounce when we are counting. You can simply say natural numbers are counting numbers. Natural numbers are counting numbers. Natural numbers are counting numbers. So we are going to give some examples of those counting numbers. Of course, we all know that the first counting number is number 1. So I'll write here number 1 as the first counting number, followed by number 2, followed by number 3, followed by number 4, followed by number 5, followed by number 6, number 7, and many more. Okay? Because they are also endless. So I have to show that natural numbers or else counting numbers, they are also endless by putting the 3 dots here. Let's move further to the next type of numbers, and that is even numbers. Even numbers. Even numbers are numbers. They are numbers that, even numbers are numbers that are exactly divisible. Exactly divisible by 2. They are exactly divisible by 2. So what does being exactly divisible by 2 mean? We are trying to talk about numbers that when we divide them by 2, when we divide a particular number by 2, that number must be exactly divisible by 2. Being exactly divisible by 2 means if we divide a certain number divided by 2, we must be able to get an answer with 0 being the remainder. Are we together? So assuming we have 10 oranges, for example, and we have 2 children sharing the 10 oranges. 10 oranges are shared by 2 children. Each child is going to obtain, or each child is going to receive 5 oranges. And then we shall have 0 oranges will remain after the 2 children sharing the 10 oranges. So in such a situation, 10 oranges are an example of an even number, simply because the 2 children were able to share that 10 oranges equally, and they remained with 0 oranges after them sharing. Remember, each of them took 5 oranges, and then definitely 0 oranges remained behind. So any number that is divisible, that is exactly divisible by 2, is taken as an even number. Are we together? All those numbers that you can divide by 2 and you remain with 0 as the remainder after the division has taken place, those numbers are referred to as even numbers. We want to look at some examples of even numbers. So I will say e.g. we shall have numbers like 0, 2, 4, 6, 8, 10. We shall have numbers like 50, numbers like 120, numbers like 400, Numbers like 1,700 and many more. All these numbers are divisible by 2. So for example, when you try to divide any of these numbers we have here by 2, trust me, you are going to get a certain answer, with the 0 being the remainder, which you get after the division has taken place. Someone should give me a brief statement, a brief sentence about odd numbers. What could be odd numbers? What do you think are they? How do you understand odd numbers? How do you tell that a number is an odd number? Yes? Anybody there? Yes, Babire? Yes? Come again? Oh, thank you very much. Wonderful. Babire has given us an answer, which is very, very brilliant. She has told us that there are numbers which are not exactly divisible by 2. We need to give her, maybe, we need to buy for her a pizza, because she's a brilliant child. Let me write what Babire has just told us. She has said odd numbers are numbers. They are numbers that are not, mark this word, that are not exactly divisible. They are not exactly divisible by 2. They are numbers that are not exactly divisible by 2. We can also continue and say they leave 1 as a remainder. They leave 1 as a remainder after division. After division. Any number that you try to divide by 2 and you find that the division is not working out exactly the way it is supposed to be, and then you find that you get a certain answer and you remain with 1. Are we together? After dividing, such a number is taken as an odd number. I'll give you an example of around 11 oranges. Still 11 oranges shared by 2 children. Of course, we shall know that we have 11 oranges. 11 oranges to be shared. 11 oranges shared by 2 children. In this kind of situation, when I try to divide and then I say I'll have 1 child here. Are we together? And then I'll have another child here. I'll have another child here. Let me say this is Veron. And then here I have Deus. So I have my 2 children. I have Veron and Deus. These 2 children are going to share the 11 oranges. How am I going to share the 11 oranges in between the 2 children? I have to give them. I have to keep giving them until all the 11 oranges are done. So I will begin by giving Veron 1 orange, and then I also give Deus 1 orange. Already those are 2 which have been given. So I continue. Veron 1, Deus 1. Those are 4 already. Remember, I am going to give them until I reach 11. So if these are 4, 1, 1. Those are already 6. I continue. 1, 1. Those are already 8, because I have 1, 2, 3, 4, 5, 6, 7, 8. Then I continue 9, 10. And then I will remain with 1 orange. I'll remain with, actually I don't need to write this one this way. I'll remain with 1 orange. So I'll realize that Veron has got 1, 2, 3, 4, 5. Veron has got 5 oranges. And then Deus has also got 1, 2, 3, 4, 5. Deus has also got 5 oranges. But then I have remained with 1 extra orange. Now this one I will not give it to any of the 2, because if I decide to give it to Veron, Deus will complain. Not so. And if I gave it to Deus, Veron is going to complain. So to be safe, or to be fair enough, I need to keep this orange aside. So this kind of number, 11 oranges, are we together? Qualifies to be called an odd number. Reason being, it has not been shared equally by the 2 people. After sharing that number between the 2 people, we remained with one orange, which is extra. Are we together? So 11 qualifies to be called an odd number. A number that is not exactly divisible by 2. A number that when we try to divide it by 2, it leaves one as a remainder. It leaves one as what? A remainder after the division. So shall give some examples of odd numbers. Of course, we said 11 is one of them, but let's start from the first one. We have 1, and then we have 3, we have 5, we have 7, we have 9, we have 11 that we just looked at right now. Then we also have 13, we have 15, and many more. All those are what we call odd numbers. I hope we are moving together. Yeah, so we want to look at the next one, and that is prime numbers. Prime numbers. Want to look at prime numbers. Yeah, what could prime numbers be? This time around I want a boy to give me the answer. Last time Babire gave us. Now Deus, you are going to give us the answer. You are going to tell us something that you know about prime numbers. Yes, can we listen to Deus? Yes, Deus, what are prime numbers? Oh, wonderful. Deus has just told us what prime numbers are. And here is his answer. He says prime numbers are numbers. They are numbers. They are numbers with only 2 factors. They are numbers with only 2 factors. And those factors are 1, the number 1, and the number itself. Are we together? Those are what we call prime numbers. That's what Deus has just told us, that any number which has got only 2 factors, and those 2 factors are already known. There is 1 and itself. We may look at some examples. For example, we can say 2. For example, 2 is a prime number simply because when we say 2 come down here, we can only multiply 1 times 2. And then we get 2 as the answer. Or else we can divide 2 divided by 1. And then we get 2 as the answer. It means 1 and 2, they qualify to be factors of 2. Just like here, 2 and 1, they qualify to be factors of 2. 2. So I can say factors of 2 include 1 and the number itself, which is 2. So you realize that 2 has got only 2 factors, which is true according to Deus, who told us that a prime number is a number which has got only 2 factors, and that is 1 and itself. So let's go to another one. We have a number like 3. We have a number like 5. We have a number like 7. A number like 11. A number like 13. A number like 17. 19. And many more. We've listed very many of them here. We've seen how 2 qualifies to be a prime number. We've just said that 2 qualifies to be a prime number simply because it has got only 2 factors, and that is 1 and 2 itself. So want to look at some of these again. I'll pick randomly, maybe number 5 again. How does 5 become a prime number? How does it qualify to be called a prime number? Of course, still, when I multiply 1 times 5, I can get 5 as my answer. But I want to give you a task. Can you give me another set of numbers that I can multiply and they give me 5 as their product? Anybody in class? Can you think of a number think of a pair of numbers that you can multiply and 5 must be the answer that you get after multiplication, leave alone addition. Of course, when we say 2 plus 3, we get 5. But this is not what we are talking about. We are talking about multiplication, not addition. So let me even rub. This is not what we are looking for. Here, we want a pair of numbers that we can multiply, and 5 must be their answer. Anybody in class? I'm waiting. Yes. Boys, anybody with a pair of numbers that we can multiply and yet 5 is the answer? No boy? Okay, girls. Any girl, please give us a pair of numbers that we can multiply and then 5 must be our answer, besides 1 and 5. Also, nobody? Okay, so you realize that 1 times 5, this is the only pair of numbers that we can multiply and we get 5 as the answer. Also, when we divide 5 divided by 1, we get 5 as the answer. But I want, when we divide 5 by any other number, trust me, we are not going to get 5 as the answer. For example, if we divide 5 divided by 2, of course we are going to get 2 remainder 1, which is not what we are looking for. We are looking for a number that is exactly divisible by 5. Are we together? A number that is exactly divisible by 5 and must be able to give us 5 as the quotient. This does not qualify. So ideally it means that factors of 5 include 1 and 5 itself. 1 and 5 itself. So 5 also in this situation qualifies to be called a prime number. Let's look at another number. I think this should be the last one. Maybe a number like 19. Of course, we can only multiply 1 times 19 and we get 19 as our answer. Is there anybody arguing? Is there anybody who can give us another pair of numbers that we can multiply? And really we get 19 as the answer after multiplication. You realize there is no any other pair of numbers that we can multiply. We can only multiply 1 times 19 or 19 times 1. Of course, the two are the same. 19 times 1 is just the same as 1 times 19. So also, we can only divide 19 divided by 1 and we get 19 as the answer. What does that imply? It implies that 19 has factors like 1 and the number itself, which is 19. So when you look at all these numbers, a number like 2, a number like 5, a number like 19, they all qualify to be called prime numbers. Numbers which have only two factors, and that is 1 and the number itself, and also these other ones. And we have many more. These are not the only prime numbers we have. We have many more of them. But so long as a number has got only two factors, and that is 1 and the number itself, that number qualifies to be called a prime number. If a prime number has only two factors, then a composite number has more than two factors. So we can write a simple statement that says composite numbers are numbers, they are numbers with more than, they are numbers with more than two factors. They are numbers with more than two factors. Yeah, all numbers which have got more than two factors. And of course, there are two ways of getting factors of a number. As you see here carefully, you can multiply two numbers and then you get factors of a number. Or else you can also divide that given number by different counting numbers, and then you'll find factors of a particular number. So even here, a composite number is a number which has got more than two factors. Any number with more than two factors qualifies to be called a composite number. So we are going to look at some examples as usual. We are going to look at some examples. I'll begin with the first one, and that is 4. 4 is the first composite number. Why does it qualify to be the first? Why is it a composite number in any way? It is a composite number simply because it has more than two factors. Let's look at factors of 4. Yeah, so I have multiplied 1 times 4. Are we together? And because I have multiplied 1 times 4, 1 and 4, they qualify to be factors of my number, which is 4. And since the two numbers give me 4 as the answer, my answer has to be a multiple. It has to be what we call a multiple. That's why you find behind your book, we have a multiplication table. That table has got factors and multiples. It has two numbers which are multiplied to get a certain answer. The two numbers that are multiplied on that table, for example, this kind of book, I know some of you have it. It has a table behind here, and this table is called a multiplication table. When you look at that table, it has two numbers which are multiplied. Those two numbers which are multiplied, they are called factors. And the answer that you get after multiplying the two numbers, that answer is called a multiple. So that's why this table has answers which are multiples. And that's why we call it a multiplication table. A table that gives us multiples, which multiples are obtained by multiplying factors of a particular number. Even here, when we multiply 1 times 4, we get 4 as our multiple. So 1 and 4, they become factors of 4. I can also multiply 2 times 2, and still I get 4 as my multiple. So it means 2 qualifies to be a factor of 4. Are we together? If I'm to list factors of 4, I have to write here that factors of 4 include, now I pick all my answers from here. Factors of 4, they are already here. I have 1, which is this one. I have 2. Now, since 2 is appearing twice, I don't need to write it also there 2 times. I'll just write it once, and that very 2 will represent both 2's that we have here. So I have 2 And then I have another one which is 4. And they are finished. So when you look at that list has got more than 2 factors. Of which number? Of 4. Which is true according to our definition here, or according to our statement, which says a composite number is a number with more than 2 factors. Indeed, 4 qualifies to be called a composite number because you have just seen it very well from here that it has more than 2 factors. I want us to look at another one. Of course, 5 will not appear here because we've just said that 5 is a prime number. A number cannot be a prime number at the same time when it is a composite number. So we shall skip 5 and then we shall go to the next one, which is 6. Our next prime number must be 6. And we want to see how does it become really a prime number. We are also going to take it through the same procedure that we did to number 4, which is also our composite number. So we are going to write factors of 6. And of course, as we are writing factors of 6, we expect 6 to be our multiple. So we shall begin with 1 times 6. These are the 2 factors of 6. Of course, when we multiply them, they must be able to give us 6 as our multiple. We shall also multiply 2 times 3. When we multiply 2 times 3, we also get 6 when it is still our multiple. Remember, we said all numbers that are multiplied to get a particular number are called factors of that number. And the answer that is got after multiplying a pair of numbers, that answer is referred to as a multiple. So in this situation, 1 times 6 will give us 6. All these numbers we are seeing here, they qualify to be factors of 6. Meanwhile, since these numbers were able to give us 6 as the answer, 6 qualifies to be a multiple in this situation. We can now list down all the factors of 6. Here, we can say factors of 6 include, we have the first one, which is 1, followed by 2, followed by 3, followed by 6, and they are finished. I've listed all of them there. The list is a list of factors of 6. 6, we said, is another example of a composite number. A composite number being a number which has more than 2 factors, which is totally true here. When you look at this list has more than 2 factors of 6. So 6 really qualifies to be called a composite number. And we have others like 8. I believe you know what to do to 8. On this table, you can write the factors of 8 and then make sure that 8 is the constant multiple. And then we also have another one, 9. We have also 10. We also have 12. We also have 14 and many more. So all those numbers are composite numbers simply because they have more than 2 factors. Remember, I told you a number cannot be a composite number at the same time a prime number. When you study this list carefully, we have 4. Here we don't have 4. This is a list of prime numbers. We don't have any 4 here. We have 6 on a list of composite numbers, and on a list of prime numbers we don't have any 6. So when you look at the 2 lists carefully, There is no digit which appears here and it appears the other side. So a number has to be a prime number, but not a composite number. And also, a number has to be a composite number, but not a prime number. Having looked at composite numbers, hopefully we have understood very well the difference between prime numbers and composite numbers. We can now move to the next type of numbers, and that is triangular numbers. Triangular numbers, just like the name says, triangular. What is something which is triangular? Triangular is possibly something which has three sides. Are we together? Coming from the figure, a triangle. A triangle is a shape which has got three sides. So we also have types of numbers. We have numbers that can give us a shape of a triangle. How do we come up with what we call triangular numbers? Most of the time, we simply need to add consecutive counting numbers. The good thing, we looked at counting numbers or natural numbers in the start of our lesson. They are right here. These are natural numbers or counting numbers. So if we need to come up with what we call triangular numbers, we are going to add consecutive counting numbers together. The word consecutive means something which comes after the other. For example, in a primary school, we have classes in a consecutive arrangement. We have classes right from primary 1 to primary 7. But you can't skip from P1 and then you go to P7. There is a class which is consecutive to P1 before you reach P what? P7. So the next class is P2, followed by P3, followed by P4. So those classes are consecutive. They come one after the other. Even here, I've told you that for us to come up with what we call triangular numbers, we are going to keep adding consecutive counting numbers. By the time we reach triangular numbers, you must be remembering what counting numbers are. Let me just write a simple statement here that triangular numbers are numbers. They are numbers obtained is the same as got by adding consecutive counting numbers. Another person can decide to call them natural numbers, counting numbers. So here this statement tells us very well how we obtain triangular numbers, that we simply need to keep adding consecutive counting numbers. We are going to try it out from our table here. We are going to add counting numbers right from this other side of the table. Then the answer that we shall get, the sum of the counting numbers we are adding, will provide us triangular numbers this other side. Remember, we said the first counting number gives us exactly the first triangular number. I'll write here the first counting number is 1, and it automatically gives us the first triangular number, which is 1. Are we together? And then to get the next triangular number, we must add consecutive counting numbers. So which number comes, which other counting number comes after 1? And that must be number 2. So we are going to add number 1 plus the next counting number, which is number 2, and that will give us number 3. 1 plus 2, the answer has to be 3. 3 becomes the next triangular number. And then after that, we are again going to add. Remember, we are going to keep on adding these counting numbers which are consecutive, which come one after the other. From here we are going to add the next 1 plus the next counting number, which is 2, plus the next counting number, which is 3. So you realize these 3 numbers are all counting numbers, and they come actually one after the other. So when we add 1 plus 2, we shall get 3. And then 3 plus 3, that should be able to give us 6. So far we have 3 triangular numbers here. We have number 1, we have number 3, we have number 6. So that is the pattern coming from triangular numbers. And remember, to come up with this pattern, you basically need to do what we are doing this way. We are going to continue. We are going to add again more counting numbers. 1 plus 2 plus 3 plus the next counting number, which is 4. So we are going to add this. 1 plus 2, that is 3. 3 plus 3, that is 6. 6 plus 4, that should be 10. And therefore 10 becomes our next triangular number. So we are continuing. We shall have 1 plus 2 plus 3 plus 4. And then we have to remember to add the next counting number, which is 5. And that will give us another triangular number that we are going to write here. So let's find that triangular number. Smart mathematicians like you must have already got the answer. Of course, let's go. 1 plus 2, that is 3. 3 plus 3, that is 6. 6 plus 4, that is 10. And then 10 plus 5, that should be 15. So 15 becomes our next triangular number. Let's continue and we find more of them. We shall say 1 plus 2 plus 3 plus 4 plus 5 plus 6. Still, to get the number we are going to write here, we are going to find the sum of these. We say 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. And 15 plus 6, that should be 21. 21 becomes our next triangular number. And then we have to find the next one by also adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Are we together? We begin from here. 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 plus 6, 21. 21 plus 7, 28. Are we together? Yeah, so basically as of now, we are not going to find all the triangular numbers we are having in this world. But by us looking at some of them, like the ones we have written here, I guess you have understood the idea behind how we go ahead to find what we call triangular numbers. Are we together? Remember, we said triangular numbers are obtained by adding consecutive counting numbers. The very way we have done here. So if you want to get another triangular number, that is, just do what we have just done here. And for your own information, I'm also going to show you a formula that we can use to calculate a triangular number. But before we go there, or before we learn that formula, I wanted to show you that these numbers, these counting numbers we are adding here, they can actually give us what we call triangles. When we can come up with triangles from these very counting numbers that we have written down here. So for example, here we can get the first triangular number coming from this number. We can also get we can get a triangle coming from these numbers that we have added here. So we have 1 plus 2, meaning that I'm going to put 1 dot and then I add 2 more dots. So this 1 dot represents this number and these other 2 dots represent this other second number. So you realize that when you connect these dots, you will come up with what we call a triangle. The same applies here. We shall put 1 dot for this number, then we shall put 2 dots. Are we together? Then we shall put 3 dots. 1, 2, 3. And when we connect these dots, we shall still come up with what? A triangle. That's why we said these triangular numbers, they give us what we call a triangle. They come from actually triangle. That's why they are called triangular numbers. Maybe one more, even these ones. We just say 1 dot for digit 1, and then 2 dots for digit 2, and then we have 3 dots for digit 3, and then 4 dots, 1, 2, 3, and 4. You see, we have a triangle there. When we connect them, we come up with what we call a triangle, and the same applies to these other ones. These are counting numbers being added. Actually, they are consecutive counting numbers being added to obtain triangular numbers. We are also going to use a formula to find just one triangular number. Are we together? We are going to look at an example. Like when we look at this example right here, it says, what is the fifth triangular number? We don't want to know about all the rest of the triangular numbers we have in this world. But our point of focus is only the fifth. We want to know what is the fifth triangular number. Are we together? And I say we can use a formula for us to derive or for us to come up with that fifth triangular number. And that formula is n, open the brackets, n plus 1, close the bracket. All these divide by 2. Are we together? But remember, in this formula, n represents the position. Represents the position. N represents the position of the number. It represents the position of the number. So our formula is n, open the brackets, n plus 1, close the brackets, all that divided by 2. So I've told you this n here is representing the position of the number we are working with. Like in this case, the position of our triangular number is the fifth. Are we together? We are going to continue to replace n by the position that is given in the question. So we are going to say 5 is the position, because fifth ideally means number 5. Are we together? If you are the fifth in a class, then you are number 5. 5, open the brackets, 5 again, because we have another n inside, plus 1, and then we close the brackets. All this divided by 2. So when we continue, we have brackets, so we have to first work out what is there in the brackets first. We shall say 5, open the brackets. Inside the brackets we have 5 plus 1, which will give us 6. Then we close the brackets, all that divided by 2. Are we together? Then we have to work out, we have to eliminate these brackets by simply saying 5. When we are eliminating the brackets, we have to multiply whatever term is outside the brackets by another term which is inside the bracket. So we are going to say 5, which is out, times 6, which is inside, all that divided by 2. So the brackets has disappeared. and it has been replaced by the multiplication operation. So when we multiply 5 times 6, that should be able to give us 30. And then 30 has to be divided by 2. And when we divide 30 divided by 2, we shall get 30 divided by 2 will give us around 15. The number we are looking for is 15. The triangular number we are looking for is number 15. We are going to check whether really it is true, whether 15 is the 5th triangular number. Remember, our question was asking that what is the 5th triangular number? And now we have got our answer as 15. Let's just move backwards to the previous work that we were looking at when we are finding triangular numbers. 15 appears somewhere here, but let's count the position where 15 is located. We have 1, 2, 3, 4, 5. So you realize that the number 15 appears in the 5th position. So it means our answer in this situation is correct, because even when we look at this list here, we really find that 15 is appearing in position number 5. We want to look at another example still when we are using a formula. So we want to use the same formula to handle this question, which says, what is the 7th triangular number? Still, we shall begin by writing our formula, which says n, open the brackets, n plus 1. All this divided by 2. N, open the brackets, n plus 1, close the brackets, all that divided by 2. And remember, we said n in this situation represents the position of the number that we are looking for. So here the position given is 7th. So we are going to say 7 comes to replace n, open the brackets, 7 again, plus 1, close the brackets, all this divided by 2. As we continue, we have to work out what is in there, what is inside the brackets first. We shall say 7, open the brackets, 7 plus 1, which are inside the brackets, will give us 8. And then we close the brackets, all that divided by 2. Up next, we are going to eliminate the brackets, and the brackets can be eliminated by introducing the multiplication operation. So ideally it means we are going to multiply 7 times 8. All this divided by 2. And 7 times 8 must be able to give us 56. So 7 times 8 will give us 56. All that divided by 2. And of course 56 divided by 2 will give us 56 divided by 2 will give us 5 divided by 2, that's 2, remainder 1. Remainder will make 6 become 16. 16 divided by 2, we shall get 8. The number we were looking for is 28. 28 must be the 7th triangular number. 28 must be the 7th triangular number. Meaning to say that when you are listing triangular numbers, 28 must be the one in the 7th position. So let's look at our previous work again. So when we look at here, we have 28 appearing here. But let's count and prove whether really 28 is in position number 7. So we have position number 1, position number 2, number 3, number 4, number 5, number 6, and number 7. Are we together? It's true that number 28 is in position number 7. Triangular number 28 is in position 7th. Our dear learners, I believe you have understood how to find a specific number, a specific triangular number in a specific position, even if you are given just the position. And on top of that, you have also known how to use counting numbers to obtain triangular numbers. Thank you so much for being very attentive in today's lesson. I invite you to check out for our remaining lesson where we are going to look at square numbers, cube numbers, and lastly integers. Please keep following our lessons. Thank you so much for following up with the previous lessons. We've actually learned very many types of numbers. And today, yet again, we want to look at the other types of numbers which we didn't learn last time. So we have a long list here. We've learned most of them. Are we together? So our point of focus today is we want to look at square numbers. We want to look at square numbers. We want to understand how do we come up with what we call square numbers. Are we understanding? So before we go practical on finding square numbers, I'm going to write here two statements which guide us on how to come up with what we call square numbers. And look at the chalkboard carefully. Of course, the first very statement I'm going to write here is square numbers are numbers. They are numbers obtained. They are numbers obtained by adding consecutive odd numbers. By adding consecutive odd numbers. That statement is very clear, and if you have been following our lessons critically, by now you should be knowing what we call consecutive odd numbers. We were able to list down what we call odd numbers, and we must be remembering at least some examples of odd numbers. So if you know those examples of odd numbers, you just keep on adding the consecutive ones only. When you add them, trust me, their sum or the answer that you are going to obtain will definitely be square numbers. The other statement we want to write down is square numbers can also be got by multiplying counting numbers, by themselves. That is a second method that we can use to form what we call square numbers. We can also multiply a counting number by itself. And when we multiply the two, the answer that we get, the product that we shall obtain, has to be a square number. So we are going to look at examples when we are using the first method, and that is by adding consecutive odd numbers. And then we shall also look at some examples when we are multiplying a counting number by itself in order for us to get a square number. We shall begin by looking at some examples. We shall begin by finding some square numbers using the very first method. In this method, I'm going to write here odd numbers. I'm going to write here odd numbers. After writing their odd numbers, I'm going to rule and then I'm going to write here square numbers. We are going to be adding consecutive odd numbers from this other side, and then our answers will appear this other side. And remember, our answers will be square numbers. I need to list those odd numbers here. So we have 1, we have 3, 5, 7, 9, and many more. Those are the numbers we are working with. The consecutive odd numbers are here. From 1, we go to 3. From 3, we go to 5. From 5, we go to 7. From 7, we go to 9. Therefore, to get the next one, we are going to add the first odd number plus the second odd number, which is 3. So 1 plus 3 will give us 4. 4 acts as our second square number. And then to get the next one, we shall still add 1 plus 3 plus 5. When you follow here very well, you realize we are adding these consecutive odd numbers. So 1 plus 3 plus 5 should be able to give us the next square number, which is 1 plus 3, that is 4. 4 plus 5, that must be 9. Let's get one more. So to get one more square number, we shall still continue by adding these consecutive odd numbers. We shall add 1 plus 3 plus 5 plus the next odd number, which is 7. 1 plus 3 should give us 4. 4 plus 5 should give us 9. And 9 plus 7 should give us 16. 16 becomes our next square number. Here I have found 1, 4, 9, and 16 as my square numbers. I've been able to come up with those square numbers by simply adding consecutive odd numbers, which the first statement that we wrote here said that square numbers can be obtained by adding consecutive odd numbers. I guess you have understood very well how you come up with square numbers with the help of odd numbers. Right in our second example, we are going to use the second method, where we are going to multiply counting numbers by themselves in order for us to again come up with square numbers. Right here we have another method that helps us to come up with square numbers, and that method we'll simply call it squaring counting numbers. Remember, in method 1 we worked with odd numbers, but in method 2 we are working with counting numbers. But good enough, we've learnt both odd numbers and the counting numbers. It is also a walkover. I will begin by listing here a few counting numbers. I will not list all of them. So I will say the first counting number is 1, the second one is 2, 3, 4, 5, 6, and many more. I will stop from there. Are we together? So these are the counting numbers that are going to give us square numbers. How are they going to give us those square numbers? It is as simple as squaring counting numbers. We have counting numbers here. We are just going to square them. What does squaring a number means? To find the square of a number, it simply means to multiply that number by itself. Are we together? We are going to multiply those numbers by themselves. I'll simply say, if I want a square number from this counting number, I'm going to find its square. To find the square of this number, it simply means to square that number like that. And when I put power 2 on that number, I am simply meaning I have to multiply that number by itself. So I multiply 1 by itself, which is 1. And when I multiply 1 by 1, I should be able to get 1 as my answer. So from 1 as a counting number, I've been able to get 1. This time round as a square number. The same applies to 2. If I want a square number from 2, I'm going to say 2. For 2 to give me a square number, I'm going to square 2 like that. And squaring 2 simply means I multiply 2 times itself, which is 2. So 2 times 2 will give us another square number, which is 4. Of course, 2 times 2 will give me 4. So 4 becomes another square number. And then from another counting number, which is 3, I will say 3 will give me 3 squared, which is 3 multiplied by 3. And 3 multiplied by 3 will give me another square number, which is 9. Are we together? So 3 times 3, I'll get another square number, which is 9. And then from 4, I will say 4 will be equivalent to 4 squared, which is 4 times 4, which will also give me 16. From 5, I will say 5 will give me 5 squared, which is just 5 times 5. And 5 times 5 will give me another square number, which is 25. And then from 6, I will say 6 will be equivalent to 6 squared, which is 6 times 6. And 6 times 6 will be equivalent to 36. You can see carefully that 1, 4, 9, 16, 25, 36, they are all square numbers, which are exactly what we got here. You can see we have 1, we have 4, we have 9, and we also have 16. So these ones are square numbers, and also these ones are also square numbers, but we have got them using different methods. Thank you so much for being attentive. We are going to look at another type of numbers, and that is cube numbers. We've seen the two ways of getting square numbers, and the last method that we use to find square numbers is by squaring a counting number by itself. So when we look at cube numbers, we multiply a counting number also by itself thrice. We simply need to multiply a counting number by itself thrice. For a square number, we multiplied a counting number by itself. But then, a cube number, we have to multiply a counting number by itself 3 times. So, we are going to do the calculation. This other side, we are going to multiply counting numbers by themselves thrice, as we hope to get cube numbers this other side. I will still list my counting numbers here. I have 1, I have 2, I have 3, 4, 5, 6, and many more. I'm going to use these counting numbers in order for me to come up with cube numbers. How do I come up with cube numbers? We said we multiply a counting number by itself thrice, or 3 times in simple terms. If I have 1 as my counting number and I want a cube number from 1, I'm going to find a cube of 1, which is just 1 to power 3. For a square number, it was 1 to power 2. For a square number, it was 1 to power 2. But then for a cube number, it will be 1 to power 3. And power 3 means we are going to have 1 multiply itself 3 times. So inside the brackets, I will simplify 1 power 3, which is 1 times 1 times 1. You see there? And 1 times 1 times 1 should be able to give me 1 as the first cube number. Are we together? And then from the second counting number, I will say 2 will give me 2 cubed. And 2 cubed means 2 times 2 times 2. Are we together? And 2 times 2 times 2. Because 2 times 2 will give me 4. And then 4 times 2 will give me 8 as my second cube number. Remember, I said 2 times 2, I got 4. And I multiplied 4 times 2 to get 8. And then from 3, I will still say 3 cubed. Which 3 cubed means 3 times 3 times 3. Like that. This will give me a certain cube number. That cube number, I will get it by multiplying 3 times 3, which should be able to give me 9. 3 times 3, I will get 9. And then 9 times 3 should give me 27. So 27, I've got it one more time by multiplying 3 times 3 to get 9. And then 9 times 3 to give me 27. And then from 4, I will say 4 cubed. 4 cubed is the same as 4 times 4 times 4, which is going to give me a cube number, which is 4 times 4, which is 16. 4 times 4 is 16. And 16 times 4 should give me 64. 16 times 4 should give me 64. One more time, I multiplied 4 times 4 to get 16. And then 16 times this 4, which remained, I get 64. Are we together? From 5, I will say 5 cubed. 5 cubed means 5 times 5 times 5. And 5 times 5, that is 25. Not so. So if 5 times 5 is 25, 25 times 5 must be able to give me around 125. One more time, 5 times 5, I get 25. And if 25 times this third 5 will give me 125. So you can do the same for many more remaining counting numbers, and you'll be able to come up with these numbers that we are having on the right hand side this way. Remember, these numbers we have said, these are what we call cube numbers. So remember, the examiner can give you a set of these numbers. He can tell you, given a pattern of numbers like 1, 8, 27, 64, 125. He can ask you to find the next number. This kind of question, the examiner simply is testing, wants to know, do you understand which type of numbers are picked in this pattern? Do you even know how those numbers have been obtained? So if you are a person who doesn't know cube numbers, trust me, this number is going to give you a hard time. But a person like you who has just learned cube numbers, I believe this number should not be able to give you a hard time. Reason being, you know, this one was got by getting the cube of 1. This one was got by having the cube of 2. And then 27 was got by having the cube of 3. And then 64 was got by getting the cube of 4. 125 was got by getting the cube of 5. And then if you are very careful, 1, 2, 3, 4, 5. The next one automatically must be by getting the cube of 6. And the cube of 6 simply means 6 times 6 times 6. 6 times 6 will give us 36 times 6. And when we multiply 36 times 6, of course, 6 times 6, that is still 36. We regroup the 3. And then 3 times 6, that must be 18. 18 plus 3 will give us 21. Therefore, 36 times 6 will give us 216. So it means 216 must be the next cube number. 216 must be the next cube number. I guess you've understood how to work with cube numbers. We are left with just one more type of numbers. Now that we are coming to the end of our lessons, we want to look at the last type of numbers, and that is integers. We want to understand what integers are and how they look. So in simple terms, of course, integers must be a combination of negative numbers and positive numbers. But remember, 0 must be inclusive in that list of the integers that you are writing. And for your own information, you need to know that 0 is neither a positive nor a negative. Let's write brief notes, and we say integers, a combination of negative numbers with positive numbers. And remember, 0 must be inclusive. But we have said integers consist of negative numbers and then positive numbers. But remember, 0 must be taken as an independent number. 0 is neither a positive nor a negative. So we are going to draw a number line that will show a sample of the integers. I'm going to draw it right here. So I'm drawing my number line. I'll put 0 right in the middle there. After putting 0 right in the middle, the positive numbers are going to appear on the right hand side of my number line. So I will say positive 1, positive 2, positive 3, positive 4, and the positive 5. So those are positive numbers, but it doesn't mean that these are the only positive numbers we have. We have many more remaining. Due to little space that I have here, I've been able to present only the first 5 positive numbers. So we have positive 1, positive 2, positive 3, positive 4, and positive 5. I'm also going to show you the negative numbers, which will appear on the left hand side of 0. I will have negative 1 right there, negative 2 right there, negative 3 there, negative 4 right there, and finally negative 5. On our number line, we have these ones here being our negative numbers. We have our negative numbers there. And then these ones here are our positive numbers. Positive numbers. And remember, in between them, we have 0, which is neither a negative nor a positive. You are going to learn more about these numbers when you are learning that topic called integers. So watch out for it.